Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. The range is just the biggest number, take away the smallest number. Biggest number in this list is 15. The smallest number in this list is 3. So 15 take away 3 is 13. So the range is 13. For us to create the smallest number, we need to pick the smallest digits at the start of the number. So the smallest digit is 3. Then the next smallest digit is 4, next smallest digit is 5, then the next smallest digit is 8. But it wants it to be an odd number, and this is an even number. So we have to move that 8 forward 1 and have that 5 at the end. So the smallest odd number is 3,485. So with this question, we need to first of all count how many sides this polygon has. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 sides. And we just need to know that a 10-sided shape is a decagon. Now we are expected to know all of the names of shapes between 3 and 10 sides. So if you don't know them already, just sit down and learn them. There are 10 squares in total, so each square is worth 1/10. And if we count all of the shaded squares, we notice that in total there are 7 shaded squares. So that's 7 lots of 1/10 or 7/10. So a prime number is a number that is only in the 1 times table and its own times table. So 4, for example, is not a prime number because it is also in the 2 times table. 6 is in the 2 times table. 15 is in the 3 times table. 21 is also in the 3 times table. 9 is also in the 3 times table. Now 1 is a bit of a special case. The definition is that it has to be in 1 and its own times table, and technically 1 is only in one of those, so 1 is not a prime number. The smallest prime number is actually 2, but 2 is not in this list. 23 though is not in any other times table, so 23 is a prime number. So I'm going to start just by copying this question. When we're told to solve, it means we need to find out what x is, and there's a nice little strategy to be able to do that. And the first thing we do is just draw lines left and right of the equal sign. And we look at the left hand side and work out what is stopping x from being on its own. Well, this minus 10 here is stopping x from being on its own. So we need to get rid of that somehow. And we do that by doing the opposite of it. So what is the opposite of take away 10? Well, that's going to be plus 10. But you can't just do that to the left hand side, you have to do the same thing to the right hand side. So on the left hand side now we're left with just x because we've got rid of that take away 10. And on the right hand side we do 6 plus 10, which is 16. So our solution is x equals 16. I'm going to start just by copying out the question. So we've got x over 12 equals 4, and when we're asked to solve, it means we need to find out what x is. We need x equals, and the method for doing it is just by putting lines either side of the equal sign, our solving lines. And what we need to do is we need to get x on its own on the left hand side. What's stopping x from being on its own? This over 12. What does over 12 mean? Well, it means divide by 12. So how do we get rid of it? Well, we do the opposite, the inverse of divided by 12. What is the opposite of divide by 12? Times 12. Now these lines show us that whatever we do on the left hand side, we have to do on the right hand side. So we have to times 12 both sides. So on the left hand side we're left with x. On the right hand side we do 4 times 12, which is 48. So our solution is x equals 48. In algebra, we don't show the times sign, so 17 times a times b just simply becomes 17ab. I'm going to start just by writing down the number. And we're asked to round this to 3 significant figures, and basically what that means is starting from the left-hand side, it's 3 numbers that we want. So 1, 2, 3. And we're going to do our line after that third number. And you start counting the first non-zero digit. So the first digit there was 2, so we started counting. Now all the numbers to the left, or sorry, to the right, so these numbers here, will all turn to 0. But before that happens, we look at this number. Now this number, if it's 5 or more, it moves this number up by 1. If it's less than 5, that number stays the same. Now it is 5 or more, because it is 5. So it's not going to be 207, it's going to be 208. Now, a common mistake is that students write down 208. No, all the numbers to the right of that line turn to 0. So it would be 0, 0, 0. So it would be 20,000 or 208,000 exactly. Whenever we're putting fractions, decimals and percentages in order, the best way of doing it is converting them all into decimals. So here we've got 0.8, which is already a decimal, so that's just going to be 0.8. Here we've got 9/10, so 9/10 is 0 in the units column and a 9 in the tenths column. 7/25, well, something we can do with that is just times top and bottom by 4, so we get 28/100. So it's going to be 0 in the units column, 2 in the tenths column, and 8 in the hundredths column. Next thing we're going to do is draw a little place value table. And so we've got units here, tenths and hundredths. So we've got 0.9, 0.28 and 0.8. And you can see here that looking at the tenths column, that 2 means that this 0.28 is the smallest. So 0.28 is 7/25, so that's our smallest. And it says it wants it in ascending order, which just basically means from smallest to biggest. Okay, looking at that, so we've dealt with that. The next smallest is that 8, so 0.8. So 0.8 will be our next smallest. And then the largest is that 0.9. Now 0.9 is 9/10. Now always make sure that if it's given in a fraction that you don't write the decimal in the answer. You want to make sure you write what the question had with it. We've got to first of all work out how many parts there are altogether in our ratio. So we've got 51 saying yes, 7 saying no, and 13 undecided. So altogether we've got 51 plus 7 plus 13, which is 71 parts. Now each part is equal. So to find out the value of one part, we're going to do how many students there are, which is 2,911, and divide it by the 71 to find out what one part is worth, how many students are in one part. One part's worth 41 students. So each one of those parts in the ratio is 41 students. Now yes, because it goes yes, no, undecided, yes will be the 51 there. So it's 51 lots of 41 students. 51 parts with each part representing 41 students. And when you multiply those together, you get 2,091. So our answer is that 2,091 students responded with yes. The first piece of information I'm going to focus on is the fact Denver gets 8/19. Denver gets 8/19, that means that Engel and Fido together must get 11/19 because they have to add up to 1. So we're only looking at 11/19. I'm going to focus on the ratio next of Engel to Fido. So it's 9/5. And let's have a look and see, well, first of all, how many parts there are all together. So 9 plus 5, which is 14 parts. So there are 14 parts in total, and the share that they get is 11 over 19. So what I'm going to do is find out what fraction one of those parts is worth by dividing 11 over 19 by 14. So each part is worth, and I'm just going to keep this into my calculator, 0.041 blah blah blah. And we're asked to find Fido share. Well, Fido has 5 parts. So Fido has 5 parts, each of them worth 0.041 blah blah blah. I've kept it in my calculator to keep the accuracy, and when I do that I get 0.206 blah blah blah. Now we're asked to work it out as a percent, so I'm just going to times that by 100. So we have 20.676 blah 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 percent, and it wants it rounded to the nearest percent, so that would be 20%. Or actually it would be 21%, because this would round it up, so 21%. First thing we need to do is work out the area of the wall, and so to do that we're just going to multiply the 44 by the 40. So 44 times 40 is 1,760. And next thing we notice is that each tin covers 10 meters squared. So it actually means we can work out the fact that there are 1,760 meters squared in total for our wall. And if each tin covers 10 meters squared, then we will need 176 tins. That's the amount of tins we need. And each tin costs £5.70, so it'd be 176 times the 5.7, or yeah, £5.70, or you could do it as 570 pence and convert it at the end. And that gives us a price of 1003.2. And so as money, that would be £1,003.20. Mode just means the most common or most frequent, and modal is exactly the same. It's just the most frequent amount of coins we're looking for. So the students who had 3 coins in their pockets came up 15 times. Students had 4 coins in their pocket, well there were 16 of them. There were 15 students who had 5 coins, 17 students who had 6 coins, and 12 students who had 7 coins. So the most frequent amount of coins a student has in their pocket will be 6, because it happens 17 times, which is more than any other amount of coins. So we can see that the first 4 of these have already been plotted. Now it's really important that you you do the coordinate the right way around. So the first one is number and then algebra. So we're looking at this coordinate here. We're 18 on number, which would be here, and then 14 on algebra, which would be this point here. 12 on both, so 12 and 12 would be here, and then 21 and 17. So 21 and 17 would be roughly there. To answer this question, we need to cut this shape into 2 shapes. So we're going to draw a line across here, and we're going to cut it into a rectangle and a triangle. Now we need to first of all label the parts of the triangle. So the length or the width of the triangle, the base, will be the same as the base at the bottom, so that will be 20 centimeters. And we need to find the height, which is this length here, which is 90 degrees to the base. And to find that, what we can look at is the fact that the total height of the whole thing is 13, and the height of the bit we don't want is 11. So what's left over? Well, 2 centimeters will be left over, so the height will be 2 centimeters of the triangle. So let's work out the area of the triangle first. Which is going to be half times base times height. Half times the base, which is 20, times the height, which is 2, will just give us 20. Now let's work out the area of the rectangle. And that's just going to be the width times the length. Width is 20, the length is 11, so that would be 220. Then to work out the total area of the whole thing, we're just going to add those together. So 220 plus 20, which is 240. The units are all in centimetres, and so the area units will be centimetres squared. So we're going to write out the question again, just to give us a bit more space. And we're going to put in our tram lines so we can solve it. Now we're going to solve this in exactly the same way as if it was an equation with an equals in the middle. One slight difference though is if you times or divide by a negative, you've got to flip the sign, but hopefully we won't do that. Now the rule when you've got an x's on both sides is you get rid of the smaller amount. So we're going to get rid of that 4x from both sides. We're going to take away 4x both sides. And so we're going to have 3x plus 8 is greater than 23. And then we're just going to solve this normally. So take away 8 both sides. And that will give us 3x is greater than 15. And then we're going to divide the 3 both sides. And that will be x is greater than 5. To find the smallest possible width, I'm just going to do a quick number line. And all I'm going to do is put 12.2 on our number line and figure out what the next number down will be. Well, if it's the nearest tens, the next number down would be 12.1. That's the next number down it could have rounded to. And I'm just going to cut this number line in half and find out where our halfway point is. Well, the halfway point would be 12.15, and that's actually the minimum it could have been before it would have rounded to 12.1. So factorise means to put it into a bracket, and it looks like it's a quadratic here, but it's actually just a linear factorising because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10. And that will leave 2 and 3. So that's the numbers done. Next I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally I'm going to look at the u, and there's just a u on both of them I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason. So corresponding angles. And corresponding angles are equal. Now here we've got an equation and we want to solve it. So we get our lines in. We'll go first of all add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. So first thing to realise is that the formula for a volume of a cylinder is pi r squared h. So what we need to do first of all is work out the volume of the water butt that James currently has. So we're going to do the volume equals pi times the radius, which is 89 squared, times the height, which is 189. And when we do that, we get 1497,069 lots of pi. And I'll keep this in terms of pi just for simplicity. Now, what we want is we want the volume to stay the same. So we're going to keep that as the volume, 1497,069 pi. But we want the radius to change. So instead of the radius being 89, we want the radius to be 103. So times 103 squared. And we're trying to work out what the height is. Okay, so first thing we can do actually is just cross off the pi's from both sides. Actually, we don't really need them at all. And then we can get our solving things in, our solving lines, and we can divide both sides by the 103 squared. And on the left hand side we get 141.113 blah blah blah, and on the right hand side we get h. So the height will be 141.113. It says it wants it to 2 decimal places, so that would be 141.11. There's a lot going on with this question, so I'm going to start off just having a look at the total amount of money. So I'm going to do this in pence, so 2115 pence. And if each merit point is worth 3 pence, then we can work out the amount of merit points by doing 2,115 divided by 3. So that gives us 705. So there's 705 merit points. Next, have a look at the question here, this part here, where it says James has X merit points. Sarah has 4 times as many points as James, so she's going to have 4x. Robert has 69 fewer merit points than James, so he's going to have x minus 69. And we know that that equals 705 because we've just worked that out. And this feels like a solving coming on. So we've got x plus 4x plus x, which is 6x. Minus 69 equals 705. And we're going to add 69 to both sides. So we've got 6x equals 774. Then we're going to divide 6 both sides. And so we've got x equals 129. So x equals 129. That means James has 129. Sarah has 4 times more, so she will have 516. And Robert has 69 fewer, so we're going to take 69 away from that, and that will equal 60. So we're told that from 14 people who liked football, So we've got 14 people here who said yes, they do like football. So we can fill out the 14 here. Now, we're told we started with 31. Therefore, if 14 liked football, then 17 must have not liked it. Carrying on the sentence, it says 4 like rugby. So 4 of those liked rugby. And we had 14 to start off with down this strand. And so that must mean that we've got 10 who don't like rugby. So of those 14, 4 liked rugby. So therefore 10 must have not liked rugby. But what about the bottom section? This part here. We've got 17 who didn't like football. Well, it says from the people who did not like football, 6 liked rugby. So we've got 6 there, and that must mean that we've got 11 who did not like rugby. So the first thing we're going to do is work out the area of the trapezium. And the formula for that is half brackets a plus b times h. Now a and b have to be the parallel sides. So here we've got the 2 parallel sides here, which just pick a different colour, here and here. So that is a and b. And then the h is the perpendicular distance between them. So perpendicular means it hits it at right angles, so that's what we've got here. So the area would be half times a, which is 28, plus b, which is 14, times the height, which is 14. And so that would be 294. Next we'll do the circle. Now it doesn't look like we've got anything for the circle, but actually the height here is actually the height of the circle as well. So the height of the circle is the same as the diameter. So the diameter of the circle is 14. Therefore the radius would be half of that, which is 7. And the area of a circle is pi times the radius squared. So it would be pi times 7 squared, which will be 153.938 blah blah blah. Now I'll keep that in my calculator, because next thing we'll do is the shaded area part, and it says we want to work out the area of the shaded region. So the area will be the total area, which will be the trapezium, take away the area that we don't want, which is this bit here, which will be the circle. So the trapezium's 294, the circle's 153.93 blah blah blah, and when you do that you get 140.061 blah blah blah. It says it wants it to 2 decimal places, so it would be 140.06. The volume for a pyramid is 1/3 times the length times the width times the height for a square or rectangle based pyramid. And so we've got 1/3 times the 20 times the 20 times the 11, and that gives us 1466.666 recurring. And so to 2 decimal places, that is 1466.67 centimeters cubed. So we've got to first of all understand what standard form is, and standard form is a number that is between 1 and 10, but not including 10, times 10 to the power of another number. So to find out what the numbers are going to be for our standard form, we're going to just write down the decimal first, so 0.098, and we've got to put a decimal point in somewhere to make this a number between 1 and 10. So if I put it in here, that would make it 9.8, and we're ignoring the zeros to the left-hand side. So we know that our standard form is going to start off with 9.8 times 10 to the power of something. Now this times 10 is always going to be there. It's never divided by 10 or anything like that. It's always times 10. Next, we've got to find out what the power is going to be. So first of all, if it's a small number, if it's a number less than 1, which this is, it's a small number, it's going to be a negative power. And the next thing we do is work out how many jumps we had to do. So it'd be 1, 2 jumps between where the decimal point was and where it is now. So 2 jumps means it's going to be to the power of -2. First thing we need to do is work out the volume of this prism, and it's a trapezium based prism. So the volume will be the area of the cross section or area of the trapezium times the length, how 3D the prism is. So trapezium is half a plus b h and then times the length. Now A and B are the 2 parallel sides, which will be this one and this one, and then the h is the perpendicular line that hits both of them at 90 degrees, which is what perpendicular means, between the bases. So this will be the 25 meters here. So it's going to be half, and then we're going to add 1 and 5, times that by 25. The length is how 3D it is, so it would be that 10 there. So we're going to times that by 10, and that will give us 750. So it's 750 meters cubed. Now, there is a little formula we can make for the rate. So the rate of anything, for this, will be the volume gained over time. Now, with this question though, we're interested in the time it will take. It says how long will it take. So we're actually looking at the time. So it will be time equals the volume, which is 750, over the rate, which is 15. So 750 divided by 15 is 50. So it will take 50, and let's have a look. It says per minute. So it would be 50 minutes. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.